Welcome to the week of April 12th, and this is your recorded session for the week. I do want to start with a warm-up question, so make sure that at this time you have your math notebook out and you're ready to take good notes. Remember, these notes are going to help you as you work on your assignments throughout the week. So if you look down at the warm-up question, I have a circle with a sector and an angle inside the circle. And I want you to find the measure of arc ABC. So this will review what we worked on last week. And get you thinking about what we did last week as we move on to this week. So go ahead and take a moment, complete this in your math notebook, and you can click pause. And when you're ready to check your work with mine, go ahead and click play. All right, so we're finding arc ABC. That's the measure we want to find. So A to B to C, we want to find this arc that I highlighted. We know the measurement for this arc right here, or for this angle, and we want to find the arc, the exterior arc. So remember to solve this, we need to know how many total angles, or the angle measurement of a circle is 360 degrees, and 60 of those degrees are being taken up by that angle inside, and we need to find the exterior arc. So we're going to take 360 minus 60 and get 300 degrees. So the measurement of arc ABC would be 300 degrees. All right, we're going to go ahead and move on. This week, we are going to complete Unit 8, Session 3, which focuses on sector area and arc length, which is different than arc measure. And we are going to take the Unit 8 quiz, which covers Sessions 1 through 3. Just a reminder, we are on that final countdown. There's 6 weeks left in the school year, so that is adequate time to get your grade up and get some missing work in if you're a little bit behind in the course. So start thinking about how you want to end the school year, what you want your goal grade to be, and to start really focusing on that goal in these last coming weeks. All right, so area of segments and area of sectors. So let's take a moment and make sure that we understand what these words mean. Segments and sectors, which is in the title of Unit 8, Session 3. So a sector of a circle is just an area bound by two radius of the circle and their intercepted arc. So a sector will has to do with the center of the circle. So a sector is going to be the two radius, which remember, a radius starts at the center of a circle and goes out to the outside of a circle. So two radius and then their intercepted arc. All that will make up the sector, and we're going to figure out how this week how we find the area of sectors, where a segment of a circle is just a region bounded by an arc and its chord. So it doesn't have to go through the center like a sector does. A sector starts at the center because it involves two radius. A segment is just going to involve a chord, which remember, a chord goes from one end of our circle to the other side, and then the region of the area bound by that arc makes up the segment. So that's the difference. So make sure that I would suggest you draw a picture to help define these two terms so that you understand what they are. And let's move on to finding the sector of an area, a sector area of a sector. So this is the formula. Area of a sector is going to equal pi r squared. Remember, that's the area of a circle, is pi r squared. Pi r squared times, I'm going to go ahead and write this over here, times the measurement of your, I'm going to put in M here, and M represents the arc measure. Or I'm sorry, not arc measure. I'm trying to write and talk at the same time. Hold on a sec. Let me get this formula in here. So that's what it is M degrees. So area equals pi r squared divided by, or I'm sorry, pi r squared times M divided by 360. And M degrees equals the central angle measurement. The central angle measure. So that is what that M means in that formula. The M is that central angle measurement. So you're going to take pi times radius squared times the central angle measurement divided by 360. And that's what that M means in the formula. Again, it's so important in geometry that you understand what all the variables mean in formulas. So here's a perfect example of needing to know what that M means. So here is a circle down below with some measurements. We've got the radius equal to 15 and our central angle is equal to 60, and we want to find the sector area in terms of pi. So we're going to find it in terms of pi, meaning that if we have pi involved, we will leave pi in our answer. And we do. We've got pi in the formula, so we're just going to leave pi in the answer. So let's go ahead and do that. Let's find the area. So area equals pi r squared. I always like to start by just writing the original formula, and then I've got my blueprint, and I can just substitute in the given information. So since we're solving in terms of pi, I'm going to leave pi in my answer. The radius, remember the radius is where you start at the center of the circle and you go out to any side of your circle. So that is 15 in this case, and we need to square that because it's radius squared. Our central angle measurement is 60 degrees divided by 360 degrees. So please make sure when you're doing this in a calculator that you are first dividing out 60 divided by 360, or use parentheses. Type it in just how it is right now with parentheses, but it's important that when you do that 60 divided by 360 that you're doing that in parentheses. So I'm going to go ahead and take 15 squared. That gives me 225. I'm not going to multiply out that pi because we're doing it in terms of pi. And then I'm going to do 60 divided by 360. Please do this in your calculator with me right now so that you are sure you're typing it in your calculator correctly. So what I'm going to do is I'm going to type in 225 times, and then I'm going to put parentheses around that 60 divided by 360 so my calculator does it correctly. If you don't put parentheses around there, you will get a different answer. So you do need that parentheses around that 60 divided by 360. Or if you don't have parentheses in your calculator, just start with taking 60 divided by 360, get that answer, and then multiply that by 225. If you have done it correctly, you will get 37.5 pi. 37.5 pi. And we didn't have any units here, so I would just say since we're dealing with area, we would say units squared. But we didn't have like centimeters or anything, so I'm just going to put a generic unit squared. So again, please make sure you try to plug this in your calculator so you know that you're doing it correctly. All right, so that is how we find sector area. Not so bad, right? The biggest piece here is knowing what that M represents in the formula, and M represents that central angle measurement. All right, I'm going to go on to the next slide. If you need more time here to take more notes, go ahead and click pause. area of a segment. So now let's find the area of a segment, learn how to. So the area of a segment, I've got the formula up here. How you do it is you first need to find the area of a sector, which we just learned how to do that on the prior slide. And then you can see that the segment is part that we're trying to find is part of that area of a sector. So we're going to subtract out the area of that right triangle that's included in that area of a sector to find the area of just the segment. So let's go ahead and try that, and let's see how we apply that. All right, so we've got our central angle here, and we've got our radius. So we can go ahead and start with finding the area of a sector. So that's the first thing we want to do is find the area of our sector. So I'm going to put sector area up here so that I'm labeling my work. Area sector equals pi r squared. So remember, go our pi r squared times m divided by 360. So m is our central angle. So let's plug in the information given. Let's see here, the radius is 6, so I'm just going to solve in terms of pi. 6 squared, and then what is my central angle? It's 60 again, so 60 divided by 360. Let's keep going here. 6 squared is 36, so I would have pi times 36 times 60 divided by 360. And what do I get? Let's see if I can squeak my answer in here. So 36 times, make sure you put in parentheses that 60 divided by 360 to get your correct answer, and you should get 6 pi if you did your work correct on the calculator. So the area of our sector area is 6 pi. Now we want to subtract out the area of our triangle. So here's our triangle right here. There's our triangle that we need to subtract out that area. So let's take a look and focus on that triangle right here that we need to find the area. We know our central angle is 60 degrees. So remember that 60 degrees is right here. In triangles, we have a total of 180 degrees in triangles, so that leaves 120 degrees to be split between these two angles. And you'll see here that that means that each angle is going to be 60 degrees. So every angle in our triangle is going to be 60 degrees, which makes it an equal angular triangle. And remember, when all angles are 60 degrees, that also means that all the sides of our triangles are also going to be the same. So the side lengths will all be 6 because it's an equal angular triangle, so it's also an equal lateral triangle. So I'm going to go ahead now and let's redraw this triangle. And we're going to work on finding the area of this equal angular equilateral triangle. So we know that all of our angles are 60 degrees. Let's go ahead and work in a different color here. All are 60 degrees, all of our angles, and all the lengths are all 6. All of our sides are 6. And we need to find the area of our triangle. So remember, to find the area of a triangle, we're going to use 1/2 base times height. Do we know the base of our triangle? The base is 6. What about the height? Do we know the height of our triangle? We do not. Remember, a height has to form a right angle with the base. So the height we're trying to find is from here to here. That's our height. We don't have that. We do not have that. Do we know the length? If we were to focus on what we did is we can create a right triangle within our equilateral triangle. So I'm going to highlight that in yellow. So we can focus on this right triangle here. Do we know the length from here to here of that small right triangle? Well, from here to here is 6, so 1/2 of 6 would be 3. So the length from here to here would be 3. And now we know we've got a right triangle, and we also have this length from here to here. That's 6. So opposite of our right angle is our hypotenuse of our right triangle. That's 6. So what can we use to find this missing length of our height? We're trying to find the height. So remember, if you've got a right triangle and you're given 2 side lengths, you can find the third by using the Pythagorean theorem. So let's go ahead and do that. Let's use the Pythagorean theorem to find the height because we don't know what the height is, but the Pythagorean theorem is going to help us find the height of our right triangle that we created in there. So a squared plus b squared equals c squared. Remember, c squared is always our hypotenuse, which in this case was 6. So 6 squared is going to be our hypotenuse. We know the smaller leg is 3 squared, and we're trying to find our height. So I'm just going to put that as b squared. Or if you want, you can say h squared. It doesn't matter. 3 squared is 9. 9 plus b squared equals 6 squared, which is 36. Subtract 9 from both sides to work on solving for that b squared. So we get b squared equals 36 minus 9. What do you get? 27. 27. And then to find b squared, we want to get b all alone. So we're going to take the square root of both sides to find that b. So what does the height end up being? B squared, or the square root of 27, is, I'm going to do 2 decimal points, I'm going to go to 1 decimal point. Sorry, round to 1 decimal point. 5.2. So the height is going to be, the height is 5.2. 5.2. So now we know the height. The height is 5.2. And now we can go ahead and just find the area of our triangle. So the height we just found was 5.2. So I'm going to go back to my formula for area of a triangle, 1/2 base times height, and I'm going to plug in what I know. So area equals 1/2 times the base of our overall triangle is 6, and the height was 5.2. So let's go ahead and do those calculations. 6 times 5.2 is 31.2, and then I'm going to divide that in half to find our final area of our triangle, and that is 15.6. 15.6. So now, so it's time to go ahead and plug all of what we just calculated into the formula. So let's highlight again. We found the area of our sector. Our sector area was 6 pi. And then we found the area of our triangle as 15.6. So let's look back up here. To find the area of the segment, we need to find the area of a sector and subtract the area of a triangle. So I'm just going to use this formula right here as my blueprint, and I'm going to go ahead and substitute underneath, since I'm running out of room, what we just came up with. So area of our segment, equals our area of our sector was 6 pi minus the area of our triangle was 15.6. So that right there is going to be our most exact answer, 6 pi minus 15.6. Or if we want to, we could plug into our calculator, we could plug in that 6 pi and get a approximation. So 6 times 3.14 would give me 18.84 minus the area of our triangle is 15.6. So subtract those two and I would get 3.24. And that would be units. We're finding area, so units squared. So here we go. This is our final answer. Once we plug everything in, I'm going to go ahead and highlight that up here. We're kind of running out of room down there, so I went back up here. So that is how you find area of a segment. So you can see the area of a segment, we need to know how to find area of a sector in order to find the area of a segment. And just remember, when you need to calculate the area of your triangle, that you do need to find the height. And when you need to find the height, you're drawing in that height there, and it creates a right triangle, which you can always then use the Pythagorean theorem to help you find the height in order to find then the area. So I'm going to move on. If you need more time with this slide, please take a moment to write down some notes so that you have when you go to work on the assignments this week. So time to add a new term and concept to what we're studying this week. Arc length. Arc length. So we've looked at arc measure, but we have not looked at arc length. So an arc length looks very similar to an arc measure. It's the distance from here to here along the outside of our circle. So it's the distance between 2 points on a circle on the outside of your circle. Remember, we always have our central angle. So an arc length is a portion of the circumference, where remember the arc measure was a portion of the central angle, where the arc length is actually the distance between 2 points on the outside of your circle. And we know the distance along the outside of a circle is the circumference. So the arc length, since we're talking about a distance between 2 points, is going to be a proportion of the circumference. Okay? So think of it as a distance between 2 points. Two points on a circle. So we're talking about a portion of the circumference. All right, so what I want to end with today is making sure we understand the difference between the arc measure and the arc length. So again, the arc measure is equivalent to the number of degrees it occupies. It's measured in degrees. So arc measure is measured in degrees. If the central angle is 42 degrees, that means the arc measure is going to be 42 degrees. So the arc measure is some fraction of 360 degrees, where the arc length is a fraction of the circle's circumference. So it depends on the size of the circle, and it's the distance between 2 points on your circle. So arc length is going to be dependent on the size of the circle, where the arc measure, it doesn't matter the size of the circle. Since it's based on the measurement of your central angle, it will always be the same measure. So again, take in consideration that these are two different things. Arc length depends on, it's a portion of the circle's circumference, where the arc measure is going to be a fraction of 360 degrees. All right, so the arc length, you're going to learn how to find the arc length this week. We're running out of time in this section, this recording. So here's the formula that you're going to use. Arc length is 2 pi times radius times the central angle divided by 360. So if you want to click pause now and write that formula down in your notes, please do so now. I'm going to go to the last slide and go ahead and finish this up. That's a wrap. So I did an overview of what you're going to see this week, and really wanted you to understand the difference and know the terms that you're going to see, and understand the difference between arc length and arc measure, and know what segments are, segment areas, and sector areas. So it's time for your key phrase assignment. So what you need to do for the week of April 12th key phrase assignment is tell me the difference between arc measure and arc length. What is the difference between arc measure and arc length? And that is how you will get your 10 points for watching this recording. If you have any questions as you're working this week, do not hesitate to ask me. Reach out for help. Have a wonderful rest of your week. And that is officially a wrap.